AB Calculus Note Card 32, Local Extrema on an Interval. This is the 32nd lesson in the Note Card series, inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed this note card system, Local Extrema on an Interval. So let C be an interior point of the domain of the function, point meaning x value, then f of C, the associated output value, is a local relative maximum value if f of x is less than or equal to this f of C for all x in some open interval containing C, a local relative minimum value if f of x is greater than or equal to f of C for all x in some open interval containing C. And so what this looks like here, if we have a function f of x going something like this, we will have a local means within an area like this. It says local interval between x equals something and something, right? A to B. This value right here, and meaning the output value, is the local maximum, and similarly down here at the bottom of this valley, that would be a local or relative minimum. So we got a max up here, again local, relative, same meaning. We're going to go over some problems that don't really involve analysis of calculus. Is basically looking at graphs. Using the graphs of the following functions, determine the A, relative or local maximum value, and B, the local minimum values. And so we're going to put x values and y values, and basically we're just going to, for a couple of these, just look at a calculator. And so we pull up our TI-Nspire CX calculator, and I'm going to add graph, and here we have, that's problem 1, and that's what this looks like. And we should be able to see that we have a local minimum over here where the hand is, and a local maximum over here to the right. And to find out what they are, we can use our analysis tools, menu, analyze graph, and we're going to look for a minimum, and here it says lower bound, the minimum value looks like that value is going to be -3, or actually -2, where x equals -3. So local min of -2, where x equals -3. So this is quite a important thing to look at when you have a point -3, -2, for instance, like our local minimum. The local minimum is -2, but where that local minimum occurs is the x value associated. Sometimes you say where and what. Let's go look at that other value, a local maximum right here. Again, go to menu, analyze graph. We'll look for a maximum, and it says lower bound. Press over here. So we have a maximum of 2 where x equals 3. So local maximum of 2 where x is equal to 3. Okay, next, problem 2. Y equals the absolute value of x. And the absolute value of x, the absolute value function, looks like this. It looks like I'm a little bit off. I'm going to move that line segment just, there we go. And like this. So this is y equals absolute value of x. And we have a relative, actually absolute, if we just look right over here at the origin, we have a relative minimum of 0 where x is equal to 0. And I said relative minimum, but do you notice that this is also the absolute minimum? Yeah, it surely is. But if we draw a Venn diagram, okay, if we look at relative extrema, let's put it this way. Okay, absolute extrema is included within the universe of relative extrema. So just because this minimum here is an absolute minimum does not disqualify it in any way from being a relative minimum. Okay, the last one that we're going to look at here is y equals x plus 3/2 sine x for the interval from -10 to 10. And I previously entered this function. So let's go find it. There it is. And we are in radians, and we have to be there. And this is what that function looks like. And I'm not sure we can see all of them. We can see a relative max, relative min, relative max, relative min. And we're looking from between -10 to 10. So what I'm going to do is expand my window a bit to get all the values that could be. And I'm going to come down here and put my y minimum of -15 and my y maximum of 15. That should get us everything that I would expect to see here. Yeah, that's fine. So we got relative min, relative max, relative min, relative max, relative min, relative max. Again, we can use our analysis tool, menu, analyze graph, minimum, and we can get to the if we put the hand over there, we can press shift and the plus sign. There we go, shift and plus, and expand. So going to 3 decimal place, we'd say -9.702, where x equals, I'm just going to do a single min and max just to save time on this. We don't need to be here for all this. Press the plus sign, there we go, where x equals -9.702, to remember everything, and that is a minimum. So we have a relative minimum of -9.072, 9.702, yeah. Where x is equal to, again, negative 8.534. Okay, we'll get a relative max just to see what it is. We'll choose this one right here. And again, we can do that for all of them. Menu, analyze graph. We'll get a maximum. And we have that one there. And we'll choose that. And we're going to put our hand over this. Shift plus sign. So let's get our other one. What you do is you press the plus sign and we'll expand it. So I'm looking at a maximum, relative maximum of 3.419, I think it was, to the place. Three point 149, where x equals 0.149, 2.301, I guess I'll run it to, right? And again, we have several other maximums and minimums, but just to save time on this video lesson, we're just going to call that good. So again, it's just looking at the graphs, seeing what they are. That's all. Good luck, and thanks for viewing.